Imagine a cosmic showdown, a battle of giants. In one corner, we have the king of planets, Jupiter. In the other, the heart of our solar system, the Sun. They look wildly different, but are they really? Today, we're diving deep into their atmospheres to see what they're made of. You might be surprised by the similarities. Let's start with the Sun. It's a star, a massive, glowing ball of hot gas. Its atmosphere isn't a thin layer like Earth's. It's a complex, multi-layered beast. The vast majority of the Sun, about 91% of its atoms, is hydrogen. This is the primary fuel for the nuclear fusion happening in its core. The second most abundant element is helium, making up about 8.9% of the Sun's atoms. Everything else, all the other elements like oxygen, carbon, and neon, is just a tiny fraction. Scientists call these other elements metals, even if they aren't what we typically think of as metal. It's a bit of astronomical jargon. This composition is a direct result of the Big Bang, which produced almost exclusively hydrogen and helium. The heavier elements were forged later inside ancient stars. Now, let's journey across the solar system to the colossal planet Jupiter. It's a gas giant, meaning it doesn't have a solid surface like Earth. Its swirling clouds and great red spot are mesmerizing. But what lies beneath? What is this giant ball of gas actually made of? When we analyze the composition of Jupiter's upper atmosphere, we find something remarkably familiar. By molecule count, it's about 90% hydrogen. And what's the second most common element? You guessed it, helium, making up about 10% of the molecules. This is incredibly close to the Sun's composition. It's like finding a smaller, colder twin of our star hiding among the planets. This striking similarity isn't a coincidence. It tells us a story about the birth of our solar system. Scientific theories, supported by data from missions like NASA's Juno and Galileo probes, suggest that the Sun and all the planets formed from the same massive cloud of gas and dust. This is known as the solar nebula. As the nebula collapsed under its own gravity, most of the material, primarily hydrogen and helium, gathered in the center to form the Sun. The leftover material formed a spinning disk around the young star. Jupiter, being the first and largest planet to form, was able to grab a huge amount of this primordial gas before it was blown away by the Sun's solar wind. That's why Jupiter's composition is a near-perfect sample of the original solar nebula. It's a time capsule from over 4.5 billion years ago. So, while the Sun is a star undergoing fusion and Jupiter is a planet, their basic ingredients are almost identical. The main difference is mass. The Sun is about 1,000 times more massive than Jupiter. It had enough gravitational pull to ignite nuclear fusion in its core. Jupiter, on the other hand, is what some call a failed star. It's big, but not quite big enough. Scientists estimate it would need to be about 80 times more massive to trigger fusion and become a star. If it were that big, we'd be living in a binary star system. Imagine having two suns in our sky. The differences we do see in their atmospheres are fascinating. Jupiter has trace amounts of methane, ammonia, and water, which form its beautiful, colorful cloud bands. These compounds are frozen into ice crystals at Jupiter's cold atmospheric temperatures, creating the distinct white, orange, and brown swirls we can see with telescopes. The Sun is far too hot for these compounds to exist as anything but vaporized atoms. So Jupiter versus the Sun isn't really a battle. It's more of a family portrait, showing a massive parent and its largest child, both born from the same cosmic cloud. Their atmospheric compositions tell a tale of shared origins, highlighting the fundamental building blocks of our solar system. Thank you for joining our cosmic journey today. For more amazing facts and explorations of our universe, make sure to subscribe to Space Repo.